Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency specializing in building live video applications. We're here to help you take your video application live. You can learn more about us at webrtc.ventures. In our previous episode of WebRTC Live, we talked about trends in WebRTC application development for 2021. And kind of what we've learned and seen the changes with the pandemic and where WebRTC will go from here. And we also noted that at that time that WebRTC 1.0 had just become a recommended standard. So today we're going to build on that conversation by discussing what comes next for WebRTC. So to help us understand the next version of WebRTC, Bernard Aboba is joining us. Bernard is a principal architect at Microsoft, editor of the WebRTC standard, co-chair of the W3C WebRTC working group. Thanks a lot for joining us today, Bernard.
You're welcome.
So I know you also recently gave a really in-depth interview on WebRTC hacks back in December. And so I want to make sure to point that out right up front to everyone joining us today. If you haven't read that yet, definitely go check it out. A lot of great details on that. If you have read it, today's a great opportunity also to ask Bernard any questions that you may have had coming out of that. So throughout the session today, just feel free to put any questions in the chat and we'll make sure that Bernard sees them. So Bernard, let's start with WebRTC 1.0 is now official, right? Congratulations on that. I know you've put a lot of work into that.
Yeah, it now has reached the recommendation stage, which is the final stage of the W3C process. A little bit more about the process. There is an in-depth description on the W3C website. The first standardization stage is CR, which is a candidate recommendation. And that means the spec has been widely reviewed, has met the working group requirements, and is implementable. So we think of CR as the first stage, which basically tells browser vendors this is safe to implement. We think we understand it. At CR, the spec may not have been completely implemented. There's something called features at risk, which means their implementation is lacking, or there may be interoperability issues between browsers, so it's not really finished. And as issues get discovered and fixed, the spec may recycle at CR. At PR, which is proposed recommendation, you have to demonstrate adequate implementation experience. So the features at risk should have been removed. And you also have to meet other requirements as addressing all of the issues and achieving wide review within the W3C. We judge the adequate implementation experience based on what features have been implemented. That's tracked by Confluence, as well as the results of the web platform test, which measures the interoperability of the API, and the results of that WPT test, it can be found at wpt.fyi. And then after you've addressed all these things, generally between PR and recommendation, it's not a long time. In the case of WebRTC PC, it only took a few weeks, but there is the additional step of requiring approval by the W3C membership. So this is a simplified view of the W3C standards process. The first step is really adoption by the working group, followed by a first working draft, and then you get to CR, PR, and finally recommendation.
So we're recommended now, but there is still this the membership officially approves it. How does that happen?
Well, they have done that. They have voted on it.
It has been. Okay.
They're basically based on the PR draft. What happened is there were a couple of companies that said, hey, why don't you wait until the IETF has published the RFCs so you can have final references and not have to reference drafts? So we had to wait a week or two, and then the IETF finally published all the RFCs that constituted the WebRTC protocols, and then we referenced those and got to the recommendation stage.
Nice. Well, congratulations again. I know you and many others have put a lot of work into it, which we're grateful for.
Yeah.
So what is the next version? Tell us a little bit more.
So just let me give you an idea of what the WebRTC working group works on. So the first priority has been, of course, WebRTC Pure Connection, which we've now published as recommendation, and then related specifications such as WebRTC Stats and WebRTC Priority. WebRTC Stats and WebRTC Priority are not quite yet done. WebRTC Priority is being considered for candidate recommendation. There's still some more work to do on the testing of WebRTC Stats. And then another category is capture, streams, and output related specs. And there's a bunch of these, such as media capture and streams. People know that as Get User Media, which has been recycling at CR, and now we're looking to move that to proposed recommendation. There's screen capture, media capture from DOM, image capture, media stream recording, output devices, and content hints. So that's a whole body of work in the second category. The third category is what we've been talking about, WebRTC-NV, the next version of WebRTC. So simply put, this is just what comes after WebRTC Pure Connection. It involves work on multiple specifications. So it's not just a single document. And the use cases that are motivating the work are described in WebRTC-NV use cases. So there's a document that sets out what we're trying to achieve, what you should be able to do. And so if you look at WebRTC-NV use cases, you'll see two categories of use cases. One is existing use cases, which are things that were articulated in the original WebRTC use cases document, but we think we can do a little bit better. So those are things like multi-party online gaming, a mobile calling service, and video conferencing with a central server. And then there are new use cases, things that you couldn't do before that we hope you'll be able to do as a result of WebRTC-NV. These are things like peer-to-peer file sharing, Internet of Things, funny hats, machine learning, virtual reality gaming, and secure video conferencing, which is included. There are a couple of different categories there. But so that's what we're trying to achieve with the set of specifications which constitute WebRTC-NV. So the next question is, what's part of that? And there's really three categories of work. So one category is extensions to WebRTC Pure Connection. And what that means is you have Pure Connection as it exists, but you have these additional APIs that can help you do additional stuff. So for example, WebRTC Extensions is a document that describes extensions to Pure Connection. That includes, for example, APIs for things like control of RTP header extensions, including potentially encryption of the header extensions. Then we have WebRTC SVC, which adds support for scalable video coding. So you can turn on various scalability modes in your encoder. We have something called insertable streams, which is useful for things like end-to-end encryption in a conference. May also be useful for some of the AR, VR use cases. And then another category within that is the features which didn't meet the implementation of maturity requirements for inclusion in the recommendation. And that's things like WebRTC Identity and WebRTC DSCP. A second category is extensions to capture. So we've got something called Media Stream Track Insertable Streams, which is about access to raw media, whereas insertable streams is access to encoded media. And that's pretty interesting. Media Stream Track, both are interesting, but Media Stream Track Insertable Streams is really potentially for the machine learning and funny hats use cases. So this one has enormous potential because if we can get it right and get the performance, you can apply all of your machine learning technology to WebRTC. So not a very complicated specification, but has enormous potential to increase what developers can do. And then there's media capture and streams extension. This is about changing the model for capture. So today we have what I would call an application picker model, where the application provides the picker where you select the audio and video devices. The problem with that is the application then has to have knowledge of all the devices, including devices which aren't selected by the user, and this is considered a privacy problem. So media capture and streams extension is about moving to another model, which is the browser picker model. So essentially the browser provides the picker, the user chooses, and then the application only gets information about the devices that were selected. So it's a privacy improvement. You also have media capture depth stream extensions. This was something that went dormant. It's been recently revised, so you can get depth information as part of media capture. And then there are a whole bunch of standalone specifications that are not related to Pure Connection or to capture. such as WebRTC ICE, that basically allows you to build a standalone ICE transport. There's the Web Transport API, which is in the W3C Web Transport Working Group. WebRTC Quick, which is a peer-to-peer quick spec built on top of WebRTC ICE. That's in the ORTC CG. And then we have Web Codecs, which is in the process of being adopted by the W3C Media Working Group. So altogether, these things are considered WebRTC-NV. So when you use the term, it's a little bit confusing because it may not be clear which of these categories you're referring to. But basically, WebRTC-NV is not a single spec. It's this collection of things.
Yeah. So you certainly answered already one of the most common questions is, WebRTC 1.0, does that mean WebRTC is done? And pretty clearly the answer there is no, right? There's a lot more that can still be done with this. It's not obsolete or a complete standard, so to speak.
Yeah, of course, there's also the work of maintaining WebRTC, testing it, and so forth. That work is definitely not done. But yeah, there's extensions to it. There's extensions to capture, and then there are things unrelated to it, which is another category entirely. And much of the work that's unrelated is not being done in the WebRTC Working Group. It's being done in the Web Transport and Media Working Groups.
Can we go back a little bit to the media capture changes, because I think that's something that even backing up a little bit from that, the one question is, now that WebRTC 1.0 is official, does that change anything for application developers? And I think generally speaking, the answer to that is no, right? Because browsers have been implementing this for a while and people have been using it prior to the standard.
Yeah, the standard itself doesn't change. I would say that a few things are worth noting. One is that the WebRTC recommendation is synonymous with what is known as unified plan. So the Firefox and Safari browsers only implement unified plan. Chrome supports unified plan as the default, but also supports the legacy Plan B API. And many applications are, in fact, written to the Plan B API. And I think what recommendation means, in addition to a recent Blink dev has got a proposal for the deprecation of Plan B. So I think one of the things that going to recommendation implies is that eventually unified plan will be the only API in browsers. Now, we don't know how long that will take, but it is something, that is an important implication for developers, in that it means that developers should be at least prototyping their unified plan implementations if they have not already done so.
So that switch is definite, at least. That's definite now, at least. So that's one implication of the standard being official.
Yeah.
Now, so back to the media capture, though, because that is something that will change interfaces as that change rolls out. So you described that in the WebRTC Hacks article a little bit, like how screen sharing works. Can you go back to that and talk a little bit more about why that change is being made and how that'll affect apps?
So there's a pretty major difference in the privacy implications of screen sharing versus media capture today. And if you recall, in screen sharing, what happens is that it is a browser picker model. That is, the browser presents the potential types of capture that can be done, application, window, tab, and the user chooses. It's not up to the application intentionally, that was the design of the spec, to let the application influence it. And the reason we did it that way is we didn't want applications, for example, trying to convince you to share your banking app. Screen share is inherently a very dangerous thing. You can be, essentially, it can break the same origin concept, and that one origin can get information about another origin. So we were very conscious of that. And screen sharing has worked remarkably well. And so I think that was one of the impetuses, as well as reviews from the privacy team, that said, hey, there's an issue here with capture. It turns out that fingerprinting based on devices is remarkably effective. Once I know all of your devices and everything about them, I can figure out who you are to a remarkable degree of specificity. People's devices are often different. And in addition, there are some devices that you don't necessarily want people to know about, like the fact that you have a very expensive camera attached to your PC. It's not really the application business to know that kind of stuff. So those were some of the privacy concerns. Now, on the other side, moving to a very different model is going to be a big change for developers. And so there has to be a transition process. It's not something that's going to happen overnight by any means. Initially, it'll be an opt-in thing. The app will basically say, okay, I want the browser picker instead of the application picker. So it's not like developers have to be afraid that their apps will break overnight. We realize that it is a major change, particularly since developers have often put a lot of work into how they do the picking and the way they want the users to be exposed to that.
Yeah, absolutely. Yeah, I agree. There will be would certainly require some changes in almost every application I can imagine that we've developed.
Yes.
To do that. But at the same time, I certainly understand. It'll be interesting to see how, if that causes any use case impacts in situations where, where it is important that you use specific cameras. So I'm thinking, because we often do work in telehealth, thinking about scenarios where you have multiple cameras that you're using for,
right.
patient exam camera versus the camera that shows the doctor and the camera that shows the patient. Those types of scenarios are pretty common there, where you want to have some at least influence perhaps on what they're selecting in terms of the camera, and that paradigm would have to change.
Yeah, and I would also say that we've seen, because of some of the privacy concerns, we've seen operating systems get into this act as well. I'm sure you're familiar with the changes to macOS, where you actually have to authorize screen sharing on an application like a browser. Right. So you actually have multiple levels of approval. You have to approve the screen capture in the browser, and then the browser itself may have a browser picker or an application picker. So what we've seen in some of those things is that users can often get confused. They don't necessarily let their browser have the right permissions, and then you have to go in and help them fix it, and you have multiple layers. It can lead to failures. There's no doubt about it. That it can result in more complexity for the user. But anyway, this will be probably a multi-year transition process. So hopefully we'll figure all this out by the time.
Sure. Yeah, absolutely. Excellent. Just a reminder to our viewers, thanks for joining us today. If you have any questions for Bernard, feel free to put them in the chat there, and I'll make sure that he sees them. Bernard, I have a number of other questions, but I'm not sure actually if you've sort of gone through your slides. I didn't want to cut you off there. If
I have gone through the basic slides.
Okay.
Yeah.
All right. Sounds good. So then let me ask a little bit more about a little more of your views on web transport. So you described in the WebRTC Hacks article as web transport being having some similarities to WebSockets, but being more revolutionary. And I wonder if you could talk a little bit more about that.
Yeah, so I think the analogy to WebSockets is good in that WebSockets is a client-server API, which is true of Web Transport as well. What Web Transport also does in addition, though, it's not just about reliable communications. It supports datagrams. And in addition, it is more bidirectional in nature, so that, for example, while the initiation of a web transport connection is still required by the client, once that's been established, it is possible for the server to originate a reliable, either unidirectional or a bidirectional stream back to the client. The server can also send datagrams. Actually, datagrams can flow in either direction. So you basically have a fully capable channel that can do any of the communication modes that you might want. So you can do unordered, unreliable. You can do unordered, reliable. You can do ordered, reliable. Any of those things you can do within a web transport. So you get enormous flexibility. And this has the potential to make a lot of things better. But one of the ones that we've seen in some research papers is video streaming. So this would be something coming down, for example, from a server to a client, like a movie, like a Netflix, Amazon Prime, whatever. And the thing is, what we see there is sometimes you can get what's called head-of-line blocking. That is, you have a loss, maybe in a frame that you don't care about retransmitting. It's maybe not a key frame. But you there have to back everything up. You can't send any other frames. You can't send any other data till you recover that loss. But in something like a web transport, you have the ability to not have everything in the video stream be reliable. So, for example, you could require reliability for the keyframe, but then allow other frames potentially to incur losses. And so what's been shown in research is if you do it that way, you can dramatically reduce video stalls, and you can also dramatically reduce latency. So that opens up a whole number of use cases, and the web transport folks, they have their own use case document, but it includes things, for example, like watching sports together. So in that situation, you want everybody to see that goal being made, for example, at roughly the same time. And so you can dramatically reduce the latency. And that also makes it potentially a candidate for something like a cloud gaming kind of use case. So that's some of the things that you can do with web transport that you can't do with WebSockets.
Interesting. Very cool. So yeah, that's really interesting. I could imagine a lot of different use cases coming out of that for sure. Now, there's also been some comments made before that the combination of web transport and web codecs means that maybe you don't need WebRTC. Can you address that a little bit?
Yeah. So so the first thing to realize is because that web codecs doesn't have to be used with web transport, and web transport doesn't have to be used with web codecs. So they're two different things. And the trick there is web codecs can be used really with any transport. It could, for example, be used with just the WebRTC data channel. And in that kind of application, you would still obviously be using WebRTC because the WebRTC data channel is obviously part of WebRTC, but you wouldn't necessarily need to use the encoding or decoding functionality that you have in WebRTC. So you could actually conceivably build an application that encoded or decoded audio video without any of the other functions of WebRTC. Now, so web codecs can be used with data channel, and I think you're going to see potentially some of these gaming applications which are built on data channel actually start to look at web codecs. The thing to realize also is that web codecs is competing in some sense with what we call low latency MSE. So as an example, today you see gaming applications that use data channel for transport and then low latency MSE for rendering. Basically what would happen is you could replace low latency MSE with web codecs. By doing so, you wouldn't have to containerize the media. That's what's required for low latency MSE. And so it would simplify the pipeline somewhat, and you could just decode and render with web codecs. So there are peer-to-peer use cases you can implement with web codecs and data channel. Now, with respect to web transport and web codecs, that's because web transport is client server only. It cannot replace the peer-to-peer applications of WebRTC. Now, the WebRTC Quick Spec, which I mentioned below, that is the peer-to-peer version of web transport. We did have an origin trial of that in 2019, but that trial is obsolete. We used the old web transport API before it moved to streams, and also it was based on Google Quick, G-Quick, rather than the ITF Quick. So that code's been removed. And as far as I know, there are no current plans to provide a peer-to-peer transport equivalent to web transport. So I would say that I would think of web codecs plus data channel for the peer-to-peer, and then web codecs for transport for the client-server use cases.
Okay. All right.
Yeah.
Thank you. I have a question from John here, who first says, thank you for a great update. And do you have any comments on peer-to-peer IoT use cases? For example, support for HTTP over WebRTC data channel directly from the end user's mobile device to their smart home hub?
Yeah, so we've had a bunch of IoT folks come in and ask for those use cases. We're still parsing through all the requirements that result from the IoT needs. And I would encourage people who have specific IoT needs to articulate those. A couple of the IoT use cases have related to changes to ICE. And for example, they wanted ICE to operate a little bit differently. Those have been more complicated because they require more protocol work. So I think it's important to really get into the IoT needs and exactly what's required. I'll give you an example of that. When we were working in web transport, we initially had two protocols we were thinking about. One was a raw quick called quick transport. The other was HTTP3. And some of the IoT folks mentioned that they wanted the raw quick rather than HTTP because of footprint issues. And I'm familiar with some of these IoT use cases because it turns out that IoT requirements are often very similar to gaming requirements, because game consoles often have restricted resources. They're not full general purpose computers, right? They have often lower memory, and they don't, the consoles often have restricted storage. So often those two things have, we found those use cases remarkably close, but I think some of the IoT things we've been hearing recently are a little bit different because, for example, some of them are extremely low energy use cases, which ICE doesn't really satisfy now. So I guess what I would say is the data channel is becoming a more general purpose transport, is being used for more general purpose things. And the web architecture is such that it should be able to transport anything. For example, people may have been surprised that the data channel is often used to transport audio media, but really the design of MSE was such that it wasn't tied specifically to HTTP. It was there to allow really any kind of media to be transported in any way and rendered.
Okay.
Yeah.
You mentioned for those who have a very specific IoT use case, having them articulate that to you. How should they reach out?
Well, we have a WebRTC-nv repository, okay, which people can file issues. And we have had a few issues filed relating to IoT, and we're still trying to look through and understand exactly what people need for the various use cases and what we would have to do to satisfy them. But I would say overall that we're seeing an increase in interest in the data channel. All kinds of things, peer-to-peer caching has become a big deal. The gaming has become huge. And so I think we're beginning to think more of the value of some of those things and what else we need to do. Another example is UN Fablé of Apple is beginning to propose improvements to support for workers in the data channel. So you can do things in a different thread. So that's an example of potential improvements that could be made to the data channel to make it more viable for some of these use cases.
Yeah, that would be interesting. Okay. All right. Thank you. We're nearing the end of our time here. So if we have any other questions, make sure you put them in the chat now. Last one that I have, Bernard, another common use case that is getting video calls as large as possible, right? You talk about like the 7x7 grid and getting 49, 50 people into a call. What do you think is what is the best way to build that now? Or have we gone with some of those use cases? Have we gone maybe too far beyond what WebRTC was intended for? Was it intended for those sorts of larger calls? And how do you feel it's adapting?
Well, I think that's a very interesting use case because it's a kind of an arms race, and you can see why it's needed. Those of you who have kids with remote education, the teachers want to see the entire class.
Right.
They want the cameras turned on. Kids may not want to turn on the cameras, but the teachers want the cameras turned on. And so you're getting, and in university classes, it's the same thing. So there's this it's not even clear to me 7x7 will be the end of it, right? We might go to 9x9 or 11x11. Now, the thing about it is, and this is important to understand, that what this has a requirement, because you're putting potentially so much bandwidth through that connection, efficiency becomes incredibly important, and particularly you have to minimize the number of copies because you're taking in so much data and rendering it out on the screen. Now, it turns out that WebRTC is good for that kind of thing because it is there's no JavaScript in the way. For example, much of that pipeline, right, is under the control of the WebRTC binary. So I think what we're seeing, you're going to see a lot of work on removing copies. For example, Microsoft has been working with Google on what we call zero copy capture. So essentially what happens is you go from the camera into a GPU buffer without any copies. And I think we're going to be trying to move to an all GPU pipeline as much as we can. Now, the trick is, can we do that in a disaggregated model like web transport and web codecs? It's a lot harder, because the idea of that is to allow stuff to be done in JavaScript, but the problem is when you do that, you then have copies. And I've gone through the specs, and I see like at least half a dozen copies. And that would, in my belief, make it very, very difficult to duplicate some of these 7x7 galleries in a pure web transport, web codecs model today. So I think that is a very powerful argument for WebRTC as it is, because it is much more amenable to that kind of optimization than it would be if we break things apart.
Right. Makes sense. Okay. Very good. Well, thank you so much, Bernard. Appreciate it as always. And we have some requests for a copy of your slides and seeing some of the links in here, because you always do a great job of putting in a lot more links than we can certainly talk through.
Okay.
Here. So yeah, we'll get that posted if you don't mind too.
Okay, excellent. Thank you.
Yeah, thank you so much. Anything else you want to share, Bernard, or anything else coming up, or anything else you want to make sure we cover?
What I would encourage developers to do is to try out a lot of these new things. It's actually very important for you to try them out. You'll certainly find a lot of bugs, which is helpful, but also your general feedback on what can be done and not done is very, very important. Because at this stage of things, developers can be extremely influential on how things develop. So I would encourage you to do that. I would also encourage people to start looking at AV1, which has just made its way into WebRTC, because I think that's very exciting and is an important use case for many of the things we talked about.
Yeah, absolutely. I agree. All right, very good. Well, Bernard, thank you again so much for your time, and thank you all of us, everyone joining us today. We'll have this posted to YouTube in a few days and up on our blog at WebRTC.Ventures, and we'll make sure to include a link to the presentation and the links within that as well. And for those of you watching, if you have topics that you'd like to see us address on WebRTC Live, please just reach out to us. You can contact us on Twitter at WebRTC.Ventures, or leave a comment on the blog posts around this. In our next episode on March 17th, we'll be talking with Justin Williams from our team at WebRTC.Ventures about doing automated testing around WebRTC. So join us for that on March 17th. And you can follow us on Twitter at WebRTC.Ventures, or sign up for our email list to get updates about those upcoming events. So thank you, everyone, for joining us today. Thank you again, Bernard. Appreciate it. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at webrtc.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.